Hello, I guess we're live with track 4. Today, starting off track 4, we've got Joe Gray. He's going to do his talk of a Decepticon and an Autobot walk into a bar, tools for OSINT using, or OPSEC using Python. Oh, there he is. How are you doing today, Joe?
I'm good. I'm here from my secret underground lair, bunker, etc. Just excited to be here. Bummed that we live in a world that we can't do it in person, but I'm optimistic that that will change and I can bring my OSINT and social engineering havoc back to Central Florida when it is safe again.
We look forward to those days.
Indeed. So am I ready to go?
I think you're ready to go.
Okay, cool. So I have a friend that stayed in a Holiday Inn Express one time and told me that I have a face made for radio. So that being said, I'm only going to have the camera on for just a couple of moments just to say hello, get the FaceTime, prove that I'm an actual real human being and not just a Decepticon. So I want to thank everyone for coming out, everyone that came out to my workshop yesterday, and everyone that's agreeing to spend part of their day, their life with me while I share one of my pet projects with you. So I'm going to kill the camera and go ahead and get started. So again, welcome to a Decepticon and Autobot walk into a bar. This is a Python tool to help enhance one's OPSEC. So as we get started, by day, I'm a senior OSINT specialist at Complex. I have some experience with Python scripting that's increasing daily. I'm coming up with a new pet project pretty much every day to be able to spread my wings and push my limits so that I can get better and better. But I'm not a developer or a programmer by any stretch of the imagination. Another thing that I'm very interested in is machine learning, automation, data science, that type of stuff. In fact, I'm actually going to be taking calculus in the spring because I've never had to take it for my undergrad or my graduate degree, so that I can meet the prerequisites to actually go into another master's program for data science. I do frequently compete in the Trace Labs competitions, the OSINT Search Party, and Missing Persons CTF. So I do frame some of my experience from that. Those of you who know me and are aware of my background, I'm very passionate about all things OPSEC and OSINT. And I do have volunteer advisory positions with both the National Child Protection Task Force and Operation Safe Escape. Safe Escape being a very key component of this presentation because they were who I had in mind when I created this tool. Shameless plug, I am in the final stages of editing my book, Practical Social Engineering. It will be published via No Starch Press tentatively on 16 February 2021. That is an Amazon pre-order redirect domain link, so that's why it's not HTTPS. So definitely stop by the No Starch virtual booth. I don't think it's available for pre-order on No Starch's website yet. It wasn't whenever I was cloning their website a couple of days ago. Actually part of the book, but nevertheless, it'll be available there amongst other platforms as well. The competitive side of me, as I stated, I do frequently compete in the Trace Labs competitions. I've actually not updated this slide. I thought I had, but I was incorrect. The updated part is my team, the Password Inspection Agency, consisting of myself, Ginsberg 5150, TJ Knoll, and Aleth Dennis. We won the Missing Person CTF OSINT Search Party during DEF CON 28 this year. We also placed second in Missing Person CTF 5, the global one. As a solo competitor, I've placed third in the National Child Protection Task Force Missing Person CTF and won the DerbyCon SECTF. So to avoid talking about that stuff too much, let's talk about what I am not. And I am not a programmer or a developer, a mathematician, or even a data scientist, and an expert when it comes to trafficking, domestic violence, or anything within that realm. Um, excuse me for one moment. I'm going to pause so I can cough so I don't blow your ears out. One moment, please. It's a little bit early for me, so even though I'm on the East Coast, it's a little bit early for me, and I'm still getting that the morning coughs done. Um, Continuing, I want to set up a few definitions just to level set through the presentation itself. The first definition would be OSINT, open source intelligence. Basically, that is information gathered in an intelligence context from public sources. You don't have to do anything super sneaky to get it. I mean, there's a few sneaky techniques to come across some things, but I typically categorize this as using search techniques to uncover pictures of cats and casseroles. So food and pet pictures, very heavy component of what we run across with OSINT. OPSEC, Operation Security, basically that's the act or activities to masquerade things that you are doing, thus minimizing or altering your attack surface. You may take steps to eliminate or obscure the data, or my personal favorite, use disinformation or deception to make that data unreliable. And I'm going to keep this as apolitical as possible, but in the United States, we can certainly see the outcomes of disinformation and deception unfolding right in front of our faces. It used to be a foreign thing. Now we're seeing it as a domestic thing. Decepticon is a term I've been using for the past few years to describe the use of disinformation and deception to work with one's OPSEC. And then machine learning, basically that's math and algorithms used to learn, if you will, basically learning how a test data set works and how it will interact. In many cases, it's A/B testing to see which algorithm works. In many cases, it's kind of like just throwing everything at the wall and seeing what sticks. But it's a lot more precise than that. But for someone on the outside, that's probably uh, the best way to think about it. It is a subset of data science, which is basically several disciplines that we use to gain insight from data. When I'm teaching my OSINT course, I always talk about open source intelligence versus open source information. And I always talk about intelligence, the OSINT. We collect data, we analyze it, we determine if it has the intelligence context, and if it does, we retain it as long as we need to make use of it. Whereas in open source information, if we collect all of that, then we're following more of a data science technique where we collect all the data that we can about everything. And then within data science, you seek to find patterns that may not necessarily be visible to the human eye or the human mind. In some cases, they may not even be true correlations, but you seek to better understand your data using algorithms and other structures to learn about the data. AI, in addition to a marketing term that makes most of us cringe, it is the study of intelligence shown by machines as implemented through code to attempt to mimic natural intelligence. Natural intelligence being the intelligence shown by humans or animals. The final thing is a GPU, graphics processing unit. Basically, that's a specialized system that's used to to accelerate image or video processing. Within the data science world, in addition to like the cryptocurrency world, it is used to speed up processing because it's typically a lot faster than just a regular CPU. So the problem that this presentation seeks to discuss is one of the leading ways that adversaries find their ways back into the lives of their victims is via social media. So what is an adversary? In the broad stroke of everything, an adversary could just be a malicious person seeking financial gain. It could be someone that's just opportunistic. You know, it makes me think of the movie The Strangers when they say, "Why are you doing this to us?" Because you were home. And that means that it's an adversary of opportunity. But from the stroke of what we're looking at for a Decepticon, we're looking to find ways to confuse adversaries that are seeking to harm the victim, such as abusers, specifically abusers, but it could also include traffickers, nation states, and political opponents. So victims that could be public figures such as politicians, executives, especially of publicly traded companies, um, people with poor or misguided OPSEC, and then, of course, as we are framing this, victims of domestic abuse and or trafficking. So some advice that I've heard from an OPSEC perspective that I want to dissect a little bit here. First, I run into the statement of, well, why don't they just stop using that account, or why don't they create a new account, or uh, something to that effect? And while that's not necessarily a bad advice, the thing about it is it could also cue an adversary that that account is no longer in use. And I see a couple of my students from yesterday in the Discord. We kind of talked about this yesterday when we were looking for an actual missing person. We came across one of their parents' accounts, and we actually came across several of their parents' accounts. And basically, it's like, oh, well, this account's been abandoned. Let's go look for another one. So if we're doing that and trying to find a missing person, a persistent adversary, if they see that the account that once posted numerous times per day now doesn't post at all, that's going to prompt them to go look for other accounts that they may have. And people tend to use the same or similar screen names or usernames everywhere. So it allows us, from an OSINT perspective, to pivot and try to find those other accounts. So if someone just abandons the account, that doesn't do any good. Some people quite literally have to use social media for work. That could be because they work in sales, recruiting, marketing. I mean, I've been tinkering with the idea internally of completely doing away with my Facebook presence. But basically staying in contact with some family members, and the fact that I do use Facebook as part of my day job doing OSINT, which granted I wouldn't have to use my real account for that. Creating fake accounts is becoming harder and harder every day. But basically, I kind of have to use social media for work. I don't have to post to it, but I do have to use it. And then let's just be honest here. If we say, okay, well, we're not going to abandon our account and we have to deal with this, why should the victim have to live their life in fear? They should be able to have agency over their persona, their life, and their online presence, to where they should be able to be online and be safe and not have to worry about an abuser or an adversary harassing or bothering them. And let's just call a spade as well. Some victims, in this case, it may not necessarily be domestic violence victims or trafficking victims, but some victims are not even aware of the adversary until it's too late, which is something that we see over on the forensic side pretty easily. If we want to dissect this some more, another piece of advice I've heard is, well, why don't you just block the abuser? Well, they can continue to cause chaos and trauma that way. They can create fake accounts. You've got friends and friends of friends that can be problematic. The other thing that you have to worry about in that regard is that screenshots are forever. Something I talk about in my OPSEC course. You can use every encrypted communication platform on the planet, whether it be Signal, Wicker, Wire, although I don't recommend it, WhatsApp and things like that. You can use Proton Mail, whatever. that's cool if they're trying to sniff you out over the wire. But the problem that comes with this is when it is decrypted, uh, very few mitigations are in place for screenshots. Wicker will tell you about a screenshot, but you know what it can't tell you about? It can't tell you if the person you sent the message to opens it on a phone or a computer and uses a camera or another phone to take a picture of it. So even blocking them doesn't necessarily make sense. If you were to create fake accounts to get away from an adversary, and the adversary find a way to enumerate those accounts, they could report those for being fake and probably get them taken down, especially given the climate of politics that we're seeing on social media right now. Within my full 8-hour People OSINT course, I have a case study about someone who was doing OSINT to find their crush. And one of the things they did, and the reason it's a case study, you know, we don't do case studies on things that are entirely above waterline. One of the things they attempted to do was a password reset. They didn't do it for the purpose of resetting a password. They did it to find out what their email address was and to find out what kind of device they had. And at the same time, companies can still be exploited. So to be honest, if I come across someone that doesn't have any social media presence, I'm far more skeptical of that than I am someone that has some presence, regardless of how open that presence is. So that begs the question of why do we not have autonomy and agency over what we post with minimal effort? Well, in that case, enter Decepticon. So right here, this is links to the code. It's the exact same link. The only difference is one's a short link to be able to transcribe a little bit better. It's on my GitHub. There are 2 different versions of this. And of one of the versions, there's 2 versions of that. So if you look at the GitHub, there is the TensorFlow code, and then there is the PyTorch code. I have not finished the PyTorch code. I was doing A/B testing with PyTorch. It seems to be a lot faster than TensorFlow. Basically, it's faster than TensorFlow, but I couldn't get the accuracy that I was looking for with TensorFlow. And within the TensorFlow piece of it itself, I have the regular standalone version that basically just reads the account of whoever is connecting and posts in their likeness, which would be used by a victim. If you look at the SOC version, you can also input a list of Twitter users, and it will read their tweets and basically come up with something in their likeness. And that's the version of the code we're looking at today, but it can be used either way. The SOC version could be used for a victim if the victim has either deleted everything they've posted or if the victim is starting a new account. So the code itself, it's written in Python. As I stated before, we have there's the PyTorch version, but it's not being discussed today. The one using TensorFlow, it also uses Keras. I think that's how it's pronounced. I apologize if I'm wrong. I've been wrong before. It is using TensorFlow 2.20, the NVIDIA port of it, because it is running on an NVIDIA Jetson Nano. It uses pandas to organize the data into data frames. And then Keras allows us to implement an LSTM that we use to generate the text, an LSTM being a long short-term memory model. So what is a long short-term memory model? In short, it's a type of recurrent neural network, which I understand that probably tells you just as much as you knew before. So basically what that is it's a type of neural network that's going to take into account past decisions and allow those decisions to influence the possible outcome. So basically they remember, if you will, previous things learned, and that makes it very interesting to use it for things like natural language processing, which is what we're doing here. And because they are not of a fixed vector size, that makes it very ideal for looking up things like text, speech, and images. So with an LSTM, it's specifically a type of recurrent neural network that's going to learn order dependency and do sequence prediction. So that in itself is very appealing for natural language processing, because depending on which language you are speaking, there are going to be certain dependencies with certain words and phrases, and this will actually pick up on that. So basically the way it works is we use a Twitter API key to pull down the tweets. It authenticates, pulls the tweets down. Again, by default, the default version only pulls down the owner of the API key's tweets, but you can modify it using the sock code to pull down anybody's tweets, as long as that account is tied, as long as the account that the API key is tied to can view it. So if you're running a Twitter account and someone's blocked you, you cannot tweet in their likeness. So from there, we capture the text of the tweets, the full text, and the time of the tweet, and we measure lexical diversity. Lexical diversity is not that important right now, but it will be in subsequent revisions. I've got a few other things on my plate that I'm trying to get knocked off my plate before I get more in depth about it. But basically, lexical diversity is a ratio of the words used to the length of the text itself. So we tokenize it. In this case, I do word tokenization. So I break everything down into each individual word, and I write it to a bag of words, which in the data science community is called a corpus. We could also do sentence tokenization, and I plan on doing A/B testing for that. I think that would probably be more accurate. The problem is during the time frame that I was writing the code, it just did not jive at the time. Next, we collect some more stats on the text and some standard statistics, looking at things like average, median, and standard deviation. And from there, we derive our post interval. That's to try to keep things as normal as possible so that it does not seem out of the ordinary. From there, we move into the generate module. And within the, as soon as I find my mouse, there we go. In the generate module, we're going to look at the vector sizes and sequences. That's going to be based on how long the text is altogether. And then we're going to measure the number of patterns within the bag of words. We'll set up any files associated with the model so that the tool can learn from it. And then we define the model and the parameters. From there, we create a pseudo-random seed to do this. And then what happens is the code will convert all of the characters to numbers, and then it executes the model, and that's where the predictions come into play. From there, it is then converted from numbers back to characters, and then we put it through a logic check to ensure that it's less than 280 characters, that we remove any known characters and links, things that aren't necessarily common to normal written text. As I was testing this, I ran through a few instances where it would just be either a quotation mark or apostrophe, comma, repeated 5 or 6 times, and it just didn't make sense. So I had to write parsers to remove that, and that occurs during the logic check. Once all of that's done, it tweets, and then it waits for the duration of the posting interval, and then from there, after that time elapses, then it kicks off the process again. So time for the demonstration. So right here, I recorded this. So it's 4 minutes in length, but this takes a lot more than 4 minutes. You should probably expect on an NVIDIA Jetson Nano, I would say it probably takes about 25 to 45 minutes to create a tweet. So just kicking this off, it's connected to Twitter. It's retrieving the tweets. There's the tokenization. So right here, we see the bag of hashtags. So it's going to do this. It's looking for hashtags that the accounts that it's looking that it looks at have used. Here are some links. We could detonate all of these links and find out what they actually go to, because in many cases, Twitter does their own short link things, and then we can also see who's mentioned as well. So you can see here Some of these come from mine, some of these don't. So I know National Child Protection Task Force, Trace Labs, Complex, Mensa, Hacker Halted, the DC865 OWL, Sector, Conant. I know all of those are mine. AT&T, I know that's mine. Some of these others are not. So now it's going to start the analysis. It's counting the number of characters. And then from here, it's just getting the execution started. We can see that it is looking at the GPU here, the NVIDIA Tegra X1. So that's what it's looking for. And we kick off into the first epoch. I've got this configured for 7 epochs. It seems to be the most accurate without diminished returns. Anything less will not be as accurate, and anything more is more or less just a waste of time. And eventually the Python script will tell you that. So an epoch, basically it runs through the model 7 different times. So right here, I've edited this part to where it speeds up tremendously. So as we can see, this epoch is anticipated to take approximately 2.5 to 3 minutes. So I'm just letting this run through. Ultimately, we will see it go through each of them, but I'm also going to show you the back side of this as well, running a tool called JTOP that's also included within the Jetson platform that allows us to look at some of the statistics based on the CPU and the GPU and other environmental things associated with the code. So this is shifting to JTOP. Notice the GPU was pegged out and then it stopped. That tells us that it's went from one epoch to another. This is just looking at the CPUs. Right here, if we look right here, so there's the GPU memory. So my Jetson has 4 gigs of RAM. That's pretty standard. But I have allocated 50 gigs of swap space because as this code continues and continues, it does need, it stores it in memory, so it will need the swap space at some point. We have the temperature stuff right here, some voltage things as well. So then we continue. There was the drop, and then we see that indicated here on this graph as well. So this is during an epoch, and then right here when it completely drops off, that's going from one epoch to another. And then we see here the CPUs, that's fairly consistent. And then this is just looking at the memory stuff. So we see that we've got somewhere between 2.7 and 3 gigs of RAM in use. And then we have the swap space right here. Right now, less than half a gig of swap is in use. And within the Jetson platform itself, you can enable extra swap, which I did that in addition to that's 16 gigs there. And then I did another one that was 34 gigs independently as well, just to be safe. And then here, this is looking at the fans and the Jetson clocks. So the fan we can see here is at 100%. By default, it is turned off, but you can turn it on to a certain speed, or you can set it to auto, which is what I did. So now we see we're in the second epoch, and now the time is going to significantly speed up. This part kind of feels like you're watching laundry or watching paint dry or watching grass grow. So I sped this up pretty tremendously. In terms of the time, we're seeing that we're just under 3 minutes for each epoch. Also within each epoch here, we see the time, the loss improving. That's basically enhancing the accuracy. That's what I was talking about the point of diminished returns. And we save everything to an H5 file so that it can be re-imported and used later. There is a slight issue with importing that right now that I'm working on resolving, but the code obviously still works as well. So it's chugging through everything. Time flies when you're having fun, I suppose. So right here, it's about to go through and actually do the creation. So it's got the random seed. It's working on creating the tweet right now. So right here it is. I recommend season 4, episode 6 of The West Wing as a palate cleanser. Congrats on making the most amazing security metaphor I've heard in a while, kind of like this. Hashtag Decepticon at Bsides Orlando. So I manually put that into the code, and then basically we are going to let this do its thing. It's going to wait. We're not going to sit and watch it for 5 minutes. I've sped this part up as well. So we're going to let this go through and just watch it start over again. And I've modified the posting interval to make it low enough to where it works. And then right there, we see it comes right back through everything again. We see everything that was mentioned, and it starts the model all over again. And we'll see it. We're going to see it entering the first epoch. Notice the GPU is at 0 right now, or close to 0. And then we're going to see that ramp up, and then we'll know that the epoch has started again. That'll be fairly soon. And we just saw the GPU ramp up, so that tells us that we're in our first epoch, which we confirm right here. And that's all for the actual demo itself. Here's the actual code. So right here, tkeys.py, that's just where we put our Twitter API keys. Obviously, I've edited mine out so that you would have to get your own. Here's the requirements.txt of things that would need to be installed. So pandas, numpy, scipy, scikit-learn, pillow, h5py, keras, natural language toolkit, and Python Twitter. It's the method by which I use to connect to Twitter. And then because we have about 34 lines of inputs, I did this as a separate file as well. So this is just importing all the packages. And we see that over here in the main code itself. So with the main code right here, we see it just imports everything from Decepticon imports. I got some help from Adrian, Goldar, Dredjak, Bill, that guy, Nosirasic, and Jay Ferg with this. Set the encoding. So right here, we just start talking about modules. So I'm going to scroll all the way to the bottom. So this is what's going to kick off. Initially, we're going to download stop words from Natural Language Toolkit. That's not used in this version. That is basically pulling out filler words like and, the, that, and that kind of stuff. But it affects the accuracy of the code if we remove the stop words out of it. We set our current directory. We check for the existence of a subdirectory called files. If that doesn't exist, we create it. And basically, files is where we're going to store our model and things like that. So if you download this and you run it and then you try to run it again and it doesn't work, then you just have to remove the files directory and it works. From there, we establish the physical device as the GPU. And then from there, we establish the API variable, which is how we are going to authenticate. So this is just our 4 keys. We tell it tweet mode extended, so it'll pull down the entire tweet as opposed to just a preview. And then sleep on rate limit to true solely for the premise of ensuring that we don't get rate limited. If we don't set that, we pretty much limit ourselves to 32 tweets as opposed to 200. 200 being the limit of the free API. We've established a sequential model. And then the results variable, that's when we're actually going to get the timeline and pull the stuff down. Right now, it doesn't take into account replies or retweets. And then we move up to that first module that we were looking at. So going up to that first module, this is just doing the connecting to it. We're establishing the user data frame. variable, which is going to use pandas. We verify that we're in the correct directory. Users, this is that list I was talking about. These are the accounts in addition to my own that have given me consent to read their tweets and possibly tweet in their likeness. We check for the CSV file because that's what at a later time the data frame will be written to. And in doing so, this allows us to grow the data frame past 200 as time progresses. So then we either create the data frame or we import the CSV file, and then we move into tokenization. From here, we establish the bag of hashtags, mentions, and links. And then we pull everything down on a per user basis, get the full text, we get the string. I have regular expressions to be able to pull out hashtags, mentions, and links. We write those to a bagger, and with the baggers, that's just writing it, that's creating a list with the bag of hashtags, links, and mentions. Next, we move into the hopper. In doing that, we basically replicate some of the same effort. We get the UTC time, but then we convert that to epoch time. So it's a linear number that's easier to work with. And then we measure the lexical diversity. Substitute, we pull out all the hashtags, all the mentions, and then we write the full text, the epoch time, the lexical diversity, and the user to the data frame. And then we move into the sorter. The sorter is going to look at all the tweets and write them to an intermediate list. From there, we are going to initialize the tokenizer, and we're going to do word tokenization again. And basically, that's how we establish our bag of words. And at that point, we save the user data frame to a CSV file, and then we execute stats, frequency analysis, and generate. So stats, this is looking at lexical diversity of the tweets, and then the mean standard deviation of the lexical diversity, as well as the standard deviation of the times. The standard deviation of the time would be post interval. And with frequency analysis, this is just looking at the word counts. Then we move into generate. So right here, we convert the characters to numbers. We measure the input length. The input length is going to be one of the two parameters for the vector size. Then from there, we print a few things, and then we determine the actual XY values based on the length of the text. So sequence length, in this case, we set to 500 just to make things more palatable. But anyway, it's just going to append a number to character, and it's going to create its own internal working plot. It's going to measure the number of patterns based on the length of the input. And then from there, it's going to reshape it, get some more variables, build the NumPy utilities to set everything up for the y-axis. Then we're going to move into pre-model and trainer. So pre-model is where we are looking for the model. I also save it as a JSON file. We're going to look at it. That's going to be the actual model itself. We have the weights in the H5 file. We've set categorical cross entropy as the compile loss method. There are other methods. Because I don't have that heavy data science background, I basically just tinkered with it until I could get it as accurate as possible. And categorical cross entropy and RMS prop for the optimizer is what worked whenever I tested it. Obviously, as I progress in my own knowledge and comprehension of data science, this is subject to change. We do save the best only, and then from there, with the TF device, the TensorFlow device, GPU 0, this is what actually executes everything. So we have the model fit, 7 epochs, batch size of 8. You can change the batch size. I tinkered with it. I put batch size at 1. I put batch size at 1,000. The higher the batch size, the more memory it's going to eat up. So you've got to be cognizant of that. And it also correlates to the length of your text as well. And then the callbacks checkpoint, that's what allows us to read on the screen that everything exists. And then the weights, obviously, that's going to be the H5 file. Then from there, we move into modeling. So with that, it's going to create 160-bit LSTM. It's defining the shapes, the sequences. The dropout, I set it initially at 60% for the first 2 runs and then 40% for the last run. And that worked well, as did softmax activation. Again, that's something that you could tinker with as well. And it just creates all the model. So for trainer, we're going to take the numbers back to characters. As I stated before, there's our pseudo random seed that's created via NumPy. And then from there, we go into tweak creator. Within this is what's actually going to work through the pattern. So it's doing the reshaping, creating the prediction, the index, all that fun stuff. Goes into the cleanup, which is where we do the logic check. Notice all these RE subs. That's just parsing out links, hashtags, and then just erroneous characters that I saw popping up through my A/B testing. This API post update, this is what is actually going to post. As you can see here, I also append hashtag Decepticon at Bsides Orlando to it in this run. And then we go into the repeater. Right here, we have the posting interval. I've got it post interval minus a number between 0 and 480 seconds, just so that it's not too perfect. But for that, I commented it out and made it very short so that for demonstration purposes. And then from there, it runs into subsequent, and that basically kicks off the initial part of the code before we get started on everything again. So coming back to the presentation, the project, I started it around December of last year. I was working with some undiagnosed ADHD, so I ran into a lot of shiny objects, delays, and hurdles between that, life, COVID, day job, other speaking engagements, and what have you. So that was a little bit problematic at times. It was definitely a wild ride. I'd previously written some tools like WikiLeaker and the Recon NG module for WikiLeaker in Python. I've got other tools that I've written that I've just not made public yet that are also written in Python, things dealing with like EXIF stomping, meaning it just overwrites EXIF with junk data in addition to optical character recognition code, which is a different tool. But I'd been reading about natural language processing, machine learning, and how to implement things. But the thing is, in that regard, I do okay with the examples in a book, but I tend to learn more by creating my own examples and running something based on that. And that's kind of why I started this. And about the same time, I was doing more work with Operation Safe Escape. So as to be expected, in March, the project stalled. And then I joined Brian Brake's CSEC East meetup. And one of the other presenters was talking about the Jetson Nano platform. I was pretty interested about that. So I ported the code over and started working on development again. Prior to that, I was using a VM on my MacBook Pro. It was, I have a 2017 15-inch MacBook Pro. The VM I was running it in is just using the regular Mac GPU. It had 8 gigs of RAM and 3 cores, so it wasn't anything to scoff at. But it took over an hour per epoch, which was problematic. So this is what an NVIDIA Jetson Nano looks like. All in all, I have about $200 wrapped up in my Jetson Nano. So on the right side of the screen, that's the regular Jetson Nano board. As you can see, that big thing sticking up, that is the GPU. It has 4 USB ports, HDMI, Ethernet. You put everything on a micro SD card to run the operating system and what have you. So you have that, but then I also have the T300 expansion, which allows you to connect a solid state hard drive via SATA over a USB bridge, which we see in the diagram as well. So all in all, this stuff collectively is like about $120 to $130, I think. But then I've also got it in this case. My case is identical to this. The only difference is I don't have the camera or the Wi-Fi antennas on it because I just don't need it. But basically, the Jetson Nano has a quad-core 64-bit ARM processor with 4 gigs of RAM. It has the Tegra support and 128 CUDA core GPU. It's all about the CUDAs. When you look at some of NVIDIA's new GPUs, like the RTX 2080 and 3080 and all of that, you can basically you can get thousands of CUDA cores for like $600 or $800 if this is something you really want to get into. But if you're just doing it as a hobbyist type thing like I am right now, until I have an excuse to drop about $1,000 on a GPU, I'm just sticking with this. And by excuse, I mean a business use case scenario, or I write a crypto miner or something that needs it. But why do I use that platform? It's external to my regular host, so I don't have to worry about it eating up my normal bandwidth on the host, none of my processing power. It has the enhanced GPU. There was a time that Mac sold external GPUs, but they were ridiculously expensive. But having that the enhanced GPU with the CUDA cores, it allowed me to do things faster. So lessons learned for this. Data science is no walk in the park, especially if you lack that heavy math background. PyTorch is faster than TensorFlow, but from my A/B testing, it was less reliable in the output. If you're doing this on your regular account, make sure you've tweeted something of substance. I had only tweeted things promoting my courses as the Ascension, and that's exactly what Decepticon was doing. It was promoting courses that did not exist. So that's problematic. You also want to tweet fairly regularly in terms of preventing yourself from having to make modifications to the code to look more normal. I definitely recommend, if you're going to play with this, doing it on an alternative account like the one that I'm using, and I'll show it to you in just a moment, because it will annoy people. I had a few people reach out. Some people were like, hey, this is really annoying. And then I had some other people saying, hey, this is really cool. So what I ended up doing was I moved it to another account that didn't have many followers, if any. And then I tweeted saying, hey, if you want to see what Decepticon's doing, go look at this account. To try to influence the text, I also broke a few songs up into 280 character chunks, as well as some poems and written text. My examples that I used were All Star and Never Gonna Give You Up from the song perspective. Poems, The Jabberwocky. That one was to see if I could throw it for a loop. In addition to The Raven, Still I Rise, Wasteland, and We Wear the Mask. It was really funny watching the bot tweet as if it were using the language of Edgar Allan Poe while talking about OSINT. That was kind of interesting. But, you know, when you're doing anything data science related, just know there's a lot of A/B testing and a lot of hypothesizing with it. And then also factor in that when you're doing something for data science, a lot of the text that the books about data science tell you to use to train the model, they tend to be like Harry Potter and the Sorcerer's Stone, the Book of Genesis. You know, we're talking 100,000 words plus. When we're factoring in about 200 tweets at 280 characters, that's a maximum of 56,000 characters. That's an incredibly small data set for an LSTM. So you're going to have limited efficiency for that perspective. But if we think back to why this was created, this is not created to be perfect. This is created to be good enough for someone to be able to abandon that account and look accurate enough to get someone to continue to watch and try to interact with the account. I do have plans at later times to allow it to respond to DMs, to retweet and reply, but that's going to be at later times. I also have plans to port this code over to also act on Facebook and LinkedIn, but I'm kind of waiting until after this volatile election season works out, so I have a lower chance of getting kicked off the platforms. Limitations, right now it's written to make use of the GPUs and the CUDA cores. Like I said before, if you do it on a VM, you can do it. It'll just take a lot longer. I looked into leasing GPU processing in the cloud, and it is too rich for my blood. So again, the LSTM is dependent upon what your account's posted. If you've wiped the account or just set it up, you're going to need to get something posted for it to work off of. And then you may also want to consider having it read someone else's account as well to post in their likeness. That being said, I'm going to open it up for any questions, and then I've got some supplemental housekeeping stuff to share with you as well. So I'm watching the Discord for questions as I'm waiting for any of those to roll in. If you want to contact me, there's my contact information, as well as links to the GitHub repo. If you want to play with a Jetson Nano, I created an Amazon idea list. So if you go to that, it'll have everything that you could potentially need for running with a Jetson platform if you would like. Other things with me, I get asked frequently about OSINT adjacent nonprofits. So the two with a single asterisks, I have volunteer advisory positions with, that being Operation Safe Escape and National Child Protection Task Force. Other great OSINT adjacent organizations would be Trace Labs, Innocent Lives Foundation, Operation Underground Railroad, Anti-Human Trafficking Intelligence Initiative, and the Polaris Project. I do offer open source intelligence training as the OSINTian. I've got a People OSINT course. It is similar to the 4-hour workshop that I provided yesterday as part of Bsides Orlando, but the full course is 8 hours, 6 hours of instruction, and 2 hours of an applied CTF-ish is what I call it, but basically everybody in the class collaboratively seeks to find an actual missing person. So there's the times for that. The only coupon code that'll work with this is TraceLabs15, unless you took the course yesterday, and then I gave you a custom code for that. And then there's a link to my mailing list. That's where I do most of my announcements in addition to Twitter or LinkedIn. I've also got a business OSINT course. I have additional coupon codes for that. So with the use of any coupon code, not only do you get 15% off, but I also donate 15% to the nonprofit associated with the coupon code. So there's where I'm going to be offering those. I have an OPSET course that is dropping in December. So stay tuned for that. I'm also developing some other courses, Introduction to Social Engineering and Technical Social Engineering, as well as Linux for Social Engineers and OSINT, Python automation scripting and APIs for OSINT. That's basically going to teach you how to create your own tools. And then an OSINT tools course, like how to use all the popular tools. And then I'm also working on an on-demand course. So that being said, I'm going to reiterate the call for questions. Any questions, complaints, concerns, thoughts, opinions, grievances, anything along those lines? There's more of my contact information as well. Okay. Before I drop off, let's take a look at what the DC865 Owl has been posting. So this is the account that posts the Decepticon stuff. So they're pushing some Trace Lab stuff. Right there, apparently Johnson votes going to Biden. Great write-up if you have a chance to read it on public speaking. Someone's nerding out. I can already tell you I know who's posted about all the election stuff. So and actually I have code running.
Hey Joe, are you going to be hanging out in the Track 4 lobby after this?
I can for a little bit. I don't have anything planned in the immediate future. As you can see,
Okay.
Also with Decepticon, it's still running. So that being said, there'll be more tweets coming throughout the day. I'll probably terminate the process a little bit later on in the day, but I will be around for a little bit, and then I'll just put my name in the Discord chat right now with the word Decepticon. And if anybody wants to reach out to me, feel free to message me. I've also, I don't want to get too overly promotional, but I also run 2 different Discords as well, one of which being the Ascension Discord, which there's the link for it if anyone's interested there. And then I also have the I have another Discord for learning all the new security stuff. I've set it up for various types of, say, certifications and disciplines and what have you. And there's a link to that if you're interested.
Awesome.
But no harm or foul. Don't feel obligated to do so. And that being said, that's all, folks.
Thank you so much, Joe. Really appreciate you sharing all of that with us today. If anybody's got any additional questions, please hop over to the Track 4 lobby, and we will be back soon with our next speaker.
Thank you very much.
Hi, so coming up next, we've got Christopher Lopez. He's a father and SOC analyst in Central Florida who's interested in the tools and methods used
by analysts during investigations and during their analysis afterwards. He's going to drop some knowledge on us today about using regular expression, which is practically a dark art for anybody who's ever tried to get started with it. So I know I'm really excited about this one. So I'm going to go ahead and bring him on in for, here's Christopher Lopez with Regex and you. How are you doing today?
Fantastic, thank you. All right, let's jump in. We're going to talk about regular expressions. Let's do it. All right, so as stated before, I'm a father. I've been a SOC analyst for a few years now, and I am a regexer. I'm not sure if that's a term, but we're going to throw it in here. And yeah, let's jump into regex. So today, what we're going to cover with regex is, first of all, what is it? A little bit of background in the history of regex, and what's most important is how can regex help you with your day-to-day. A lot of this is going to be from a SOC analyst perspective, because that's what I do. But this can be applied to many facets of InfoSec. We're going to focus on fundamentals. That is, what's needed in order to get started with regex. And then we're going to use those fundamentals in our disassembly exercises here together. And at the end, provide some resources, for furthering knowledge of regex. All right, expectations. Regex is a big topic. In 30 minutes, I do not expect anyone to be a master. I'm not a master. I'm learning every day how to use regex even better. The only expectations I have here is hopefully there is an understanding of the fundamentals. There's a lot of that too, so I understand. And the confidence to learn more. That's what's most important here. Taking some of this from this presentation and saying, hey, that would be really interesting to do for this specific thing in my job. Why not learn a little bit more about it? So those are the expectations here. Don't worry, not too many. All right, so what is it? We've said regex a few times here. It's just short for regular expressions. It's just a combination of meta characters, as you'll see, and it's fundamentally really good at doing one thing well, and that is pattern searching. So you do that through building wildcards or mega wildcards, like I like to say, and every single part of the fundamentals that we're going to go over are just building blocks or even pieces of a puzzle that you'll put together to form an even more powerful or effective regex statement. And if you go on Twitter, you're probably going to see a lot of not so good things about regex whenever it's brought up. That's okay. It's not magic, even though it may seem like it. And we're going to try to debunk that a little bit throughout this presentation. Okay. I can't say it better than Leonardo. So learning is the only thing the mind never exhausts, never fears, and never regrets. The reason I put this in here is because regex does require a little bit of a learning curve, but that's okay. I don't regret the amount of time that I've spent learning regex because it's added a layer to my problem solving skills that I use often, especially as a SOC analyst. So he said it better than I can, so why not quote it? All right, so how can it help you? All right, you want to add a tool to your tool belt. Like, why would you consider regex in the first place? Again, being a SOC analyst, I spent a lot of time investigating and building detections or tuning detections and parsing data. And that's where I feel regex is really powerful. Let's say you see something on Twitter, which we're seeing a lot of, right? A new attack, a new way of doing something, and you want to look for a pattern that's associated to that. That's where regex can really help you. Threat hunting would be an example of that. Another one is, with SIM searches, right? So using our SIM to look for logs or certain types of activity in our environment, regex is really helpful when it comes to that. But what's most important here and what I want, the biggest takeaway to be is, we're all learning skills to be able to help us be more effective analysts or more effective practitioners of security in our field. And this is just another tool that can help us, on that journey, right? We're all on a journey here together to be better, right? So regex can help with that as well. We're going to spend a brief moment on history because it's important, just to talk about the fact that this came a long time ago. 1950s is when the thought process behind this or the concept of regex started. If you look at old Unix documentation or even current Unix documentation, you'll see that it's all over, with Unix methodologies. And it was designed for one purpose, and that's the one thing it does well, It's just improving the efficiency of searching for patterns. That's it. So we got to cover some fundamentals in this, and we're going to build into it, but I just wanted to throw some in here just to get us familiar with these words. And the first one is words. Digits, quantifiers, special characters, they're all written in a certain way in Regex, and just think of them as building blocks or Lego pieces that you're going to put together to fit your need, right? To be able to solve the problem that you're trying to solve with Regex. So that's what we're going to spend most of the time in this presentation on. Okay, here we go. First slide for fundamentals. Special characters. These are incredibly important. So we're going to spend a little bit of time here. All the way at the top. Now, it may be, there's a lot of stuff on the screen, so I apologize for that. But we're going to try to go through these one by one. One of the most powerful and important things to remember about Regex is you need to escape things, or things have escapes built in order to help with what it is that you're trying to do. So you're going to see a backslash in a lot of things here. The next one is the powerful dot. That just means anything. It matches anything that you can throw at it one time. And that's important to think about, that one time. We'll get into how to make that more later. And then we have the caret symbol or the triangle. I don't know, people have different ways of saying that. And that just means that this starts with the next following character or whatever it is I put after this symbol. And that's important, and we'll see that in examples, further along. And then the opposite of that will be the dollar symbol, which is basically the previous character, whatever's behind or in front of this symbol, it ends with this. Now, we have spaces, right? So if we want to actually, Christopher space Lopez, for example, instead of, putting a space, you actually use a \s, which signifies space. And that's another example of the escape there. Now, the next one would be no space, right? So that is \S. All right, so that's very important to think about for just a moment. A lot of Regex, there's a not when there is a capitalization, and we're going to see that in a few more examples, but just something to keep in mind as we move forward. And the last one here is just how ORs look like. ORs is just basically a straight line down the middle within parentheses. Quantifiers. Now this is how we add to that singular dot that we talked about that matches anything. So we have the plus and we have the asterisk here, right? So plus being one or more times of this specific value that I'm trying to find, and the asterisk is 0 or more times. The difference between these two sometimes gets me, even after spending some time working on Regex. So it's just important to keep those in mind, that they are different, and you'll see people write them differently. Then we have the question mark, which is optional. Now this one throws everyone off. It throws me off all the time, because you're saying it can contain this previous character. It doesn't have to. And I'll tell you a story about this. So when I first started in InfoSec at all, I came from IT, and I knew nothing about security. And I was talking to one of my new team members, and I was like, hey, what do I need to learn to be better? Because I don't know a lot of stuff here in InfoSec, and it's a little bit intimidating. And of course, one of the first things that he said was learn some kind of scripting. That's still something I'm learning, right? Development skills are very important in this field, and that's still something I'm trying to get better at. But the other thing that he said was interesting to me, and that was regular expressions. I was like, I've never heard of that before. Why should I learn that? And then he just simply said, we use it everywhere. I was like, okay, that's interesting. So I started trying to use it, and there was a day where I decided to look at proxy logs, for example, because they're interesting, and malware might bang on a proxy if it's trying to reach outbound and it's not proxy aware, right? So I'm like, let me write this really fancy regex to try to find instances of this JavaScript. I was very early. I didn't know much. It's okay, and we're all just learning as we go. And I put a bunch of these optional statements, and I ended up breaking the sim to be able to search for anything, because I didn't understand how to use regex effectively. And using regex is somewhat of a double-edged sword sometimes. So just keep that in mind, that you can create a regex statement that's really resource intensive. Okay, so moving on to the curly brackets. You can see a 3 here, and what that basically means, match exactly 3 of the previous whatever it is that I'm trying to find. You can also add ranges, which is, the 1 and then comma 3 within the curly brackets. And this all will make more sense as we break down some of these regex statements, but just something to keep in mind as we move forward. Okay, now we have words, right? So words are interesting, right? We're trying to find like ASCII characters. And then we have, for example, the \W. And then we have the \uppercase W, which actually means not, right? Like we talked about before. So it's not a word. Then we have boxes or these brackets, however it is you want to call it. And whatever you put in there, what that does is it matches against that. And as you can see, we have A through Z, which is all the letters of the alphabet, right? Or at least this alphabet. And we're trying to find all lowercase instances of that. Yes, so there is case sensitivity into some of these regex statements. That's just another thing to keep in mind. And if you want to add capitalization, you can either explicitly just put capitals, or you can put a combination of both of these into those brackets. And on the right side of the screen, we have an example string, which is just like, Christopher.Lopez@email.com. And then we have 3 different regex statements that match. Now, there's a lot on the screen. I understand that. The reason I put 3 different ones is just to emphasize that everyone is probably going to have a different way of doing regex or using regex. And that's okay. I love seeing other examples of things that people come up with in order to find the value in a search. And they use a regex statement that I was not considering. We learn from other people when it comes to regex a lot, because what I do may not be what you decide to do to match the specific value. All right, so digits, right? So we want to find an integer, we want to find an IP address, which is common, right, in our field. And, we want to look through a log file and see all the instances of a specific IP address or even a range. We can use the \d. Now, the same thing that we talked about before, uppercase just means not a digit. Or we can, put digits 0 through 9 into brackets, and that matches every number, because that's, we're on a 10-base system. So that's going to match everything, in there. And what's also interesting here, which just threw me off very early on learning regex, digits are also considered words. So if you use a \W, it will still match a digit in your statement. So just keep that in mind if you're trying to separate whether or not you're looking for ASCII characters or you're looking for digits or integers. A W may throw you off a little bit because it'll match both. And again, the same thing emphasized here is that there's multiple ways of trying to find the same value, of trying to, use regex to find an IP address, for example. All right. So now we've gone through some fundamentals. I know it was a lot of information. What will you use the most? Again, this is like Legos. So whatever works best for you, that's the best thing that I can say here, because everyone's going to look at this and approach this in a different manner. And there's so many different combinations for the same thing. Now, there are tools out there that is part of the resources here that may allow you to put a regex statement and it's able to tell whether or not it's efficient, because there is efficiency at play here sometimes. But besides that, whatever helps you learn it better, whatever solves the problem you're trying to solve. And all you need to remember really is the special characters that we talked about, quantifiers, words, and digits. And don't forget about the \W with integers, because that still gets me. All right. We're going to slow the pace down a little bit, and we're going to focus on disassembling some regex just to make it sound fancy. And this is just a random example. It doesn't mean anything. It just looks like a URL, right? Or maybe a downloaded file. And basically, we're going to run through each one of these. I try to make it color-coded so it's easier to see. I hope it's good on the screen. And we're just going to go through these one by one and what they mean. So the first thing we have here is the HTTP, right? And then we have a question mark. We have a parentheses S with a question mark. And basically what this means is it starts with HTTP, lowercase, right? And it can have an S. So this will actually find instances where it's HTTP or it's HTTPS, which is interesting. This is one way of doing it, because you could be asking yourself, well, can't you just use an or there? Yes, you can use an or here. But this is all personal preference and whatever it is that you're trying to accomplish with this. Sometimes I find myself using question marks like this, and sometimes I don't. And that's just, something to keep in mind. So the next thing is we're escaping special URL characters. So this is just using a backslash, right? Especially for the colon or the forward slashes that we expect to see in a URL. And this is just escaping those because those are characters that are, those are values that regex may not like. So it's good to just escape those. Then we have this example. So this is, right, the bracket A through Z. So that is every alphabetical character. And then we have a range in the curly brackets. So that's saying I want this to be between 5 and 15 characters in length. That's going to find a lot of domain names. Basically, that's what we're trying to indicate with this. It can be 5 through 15 characters in length, whatever it is that I'm trying to find, this ASCII character based on the A through Z. Then what we have is the top level domain. So we have a backslash dot, right? So that we can actually put the dot. And then we have A through Z again, and we have a range 2 to 3. So that can be, a .org, a .net, a .com, for example, would, come up on this type of search if you're looking specifically for that top level domain. Now, there could have been multiple ways of doing this. I could have just put .com if I wanted to find .com, for example. I could have just put, the specific alphabetic characters separated by commas if I was looking for specific characters within that, top level domain, or I can, specify 3 characters in length. I only want 3 characters for this specific type of value that I'm looking for. Then we have a subdomain, and the reason I put this here like this is because, as you can see, there was no // mentioned, and there's no / after it mentioned, and that's because the dot means anything. So we're using a dot here, and it's making the search a little bit lazy, which is okay, especially as you're learning. And this is basically matching anything until we get to the next thing, right? And the next thing here would be, one of these file-based, file types here. So that would be a dot, and then we have an OR statement, and this is how to indicate that you can have 3 different values in an OR statement. So it can be an EXE, SH, VBS. This is just an example. But yeah, so we have 3 different OR values, and then it ends like that. So there should be nothing else after that for this specific example. Okay, so we're going to move on to the next one. And this is a actual file path, not a URL, and it is broken down in the same, similar manner, but it just, basically reinforces what we've been covering. So we have an OR, right? Depending on how, your sim may parse, whether or not Windows sends it with a capital C or lowercase c. Windows doesn't seem to care about that too much, as we know. So this just helps with that in case there's anything missing. This starts with either a capital C, lowercase c, and then it escapes all the special characters for the file path. And then we have a user directory matching a first name dot last name pattern. So this would be, for example, like a Christopher.Lopez, to use my name as an example for a file path. And as we can see here, we have, the alphanumeric characters in the boxes or the brackets. We have a plus symbol on each side of that, and we just have a dot. We are explicitly stating that there's a dot here by escaping the dot in the middle. Then we have, app data, right? We're looking maybe at the temp folder or the local roaming folder. And this is basically saying local or roaming can be used in this specific value I'm looking for. Then we have a temp. So because, we're looking for local, temp, for example, or roaming, what if the temp folder doesn't exist in a specific directory that you're looking for? Well, you can say that it can be there by putting everything in parentheses and using the question mark. So that's like, it can be there, and match it if it does, but it doesn't have to be there. And that's powerful. It's a double-edged sword, but it does help if you're trying to put things together really nicely in regex. And then what we have is, can it have a backslash? It can, because if, for example, the roaming folder doesn't have a child folder, or it doesn't have a folder underneath it that is temp, well, we're trying to match against 2 of these. This may not be the most efficient way of doing it, but we're trying to match against 2 of these. So if it did, it would actually have a backslash. So that's just saying it can have it, doesn't have to. This is another thing that may throw this search and make it a little bit less efficient, but it's trying to solve that problem. We're looking for a specific file in 2 different directories. And then we have, basically I want a combination of uppercase, lowercase, digits, doesn't matter. I just want all of that, and it can be any length, right? It can be 300 characters in length. I hope there's not that file in there, but that's interesting. And then you can just match it against it ending with an executable or a BBS file. So here goes a few more examples. These are more like how can these specific regex statements help me like now? Like what can I use now? And these are some examples. We talked about domain searching, so there's that, right? We also have emails, right? A lot of us, we deal with emails every day. We may be looking at specific phishing type, reports, or looking at things that we want to, investigate, and it's email related. There's one way of doing emails, and you just match the specific domain, after the @ symbol. Then we have, for example, let's say that you're looking at proxy logs and you see that there are actual HTTP URL events where there's no actual domain name. It's actually looking for what appears to be an IP address, which, it's happened before. And you can actually match in the proxy logs for that. Then you have executables in the public directory. That's similar to what we just indicated before, just showing more ways of using the OR statement, more IP addresses. And then we have the OR, right? Another example of OR. And how valuable that is. And the last example here would be run keys, which is something that we know as a persistence mechanism for malware. It may be interesting to see things that are in that folder or anything that matches against that folder for any events or any process level events that you're looking for. Couple more. All right, so we have PowerShell. Why? Because PowerShell is everywhere, and it's really important to understand that it actually can accept regex values. And here goes an example. If you're looking for a specific 80 user, or you're using a commandlet, get 80 user, you can specify a specific, way of writing, an account in an environment. Then we have, of course, egrep, right? Linux-based stuff, and how to use egrep to find, for example, in this case, IP addresses in the auth log file. Then if we're more, pivoting over to like Azure, and we're looking at specific KQL language, and we're looking at security events for process creation events, we can also specify specific regex examples, using the exe or the BBS, and that's just another way of writing and using regex. Okay, so we're gonna wrap it up. So hopefully there's some confidence to learn some more. I mean, that's the whole point of this. There's a lot out there. Regex is very powerful, and it is a good tool to add to your tool belt. And all it takes is practice. That's it. You just got to find ways of using it. You got to find ways of, breaking things by using it. It's okay. That's how we learn. That's how I learned. And you can do it too. It's not rocket science. I mean, maybe it is. I'm not sure. It's definitely not magic. It just does require a little bit of, learning the fundamentals, which of course are the building blocks that we talked about. For repetition's sake, and to try to make sure that, this is remembered, words, digits, quantifiers, and special characters. That's all you really need. All right, and here goes some awesome resources to continue that path of learning. I'm gonna put one of my favorite text editors besides Vim up here all the way at the top, Atom. I love it for being able to match regex statements. It's just pretty, it looks nice the way that it does it. And then other examples of learning regex, like Regex 101 is really good. And there's some other examples here, like a video that I found pretty interesting, which is Bsides Tampa in 2019 for using regex in incident response. And that's it. Thank you so much.
Awesome. Thank you for sharing that info with us today. Did we have any questions coming in? I haven't seen any in the Discord. Oh, hang on, we've got one. Nathan Weber. Here we go. Oh,
Ooh.
I did that wrong.
Yeah. So am I able to write the resources? I can copy paste them onto any of the Discord channels. I think that would be most helpful for that question.
Sure. Yeah, if you want to hop over into the Track 4 lobby after this and share your resources there, I think that would be really helpful.
Awesome. Yeah, perfect.
Any other questions before we get out of here? All right, I think we're looking good.
Awesome.
Thank you so much.
Have a good one.
You too. I'm going to take this moment. We've got a few minutes before our next talk, so I'm going to throw up a screen with all of our sponsors so we can thank them. Oh, maybe not. So welcome back to track 4. We are here with Dr. Lee Mangold, who has got quite an extensive career across InfoSec. He's one of us here at Bsides Orlando, as well as a ton of other organizations. And today he'll be presenting on getting your way in security and life. Welcome, welcome.
Thank you, Tabitha. Well, thanks everyone for joining. This is sort of an interesting topic for a technical conference, what is largely a technical conference, but it's really something that is sort of near and dear to my heart. And it's something that I know hiring managers across information security, across really most fields, are really looking for. And we're going to talk a little bit about communication, but communication skills that really apply to exactly what we do, right? So before I get started, just a really quick kind of background on myself. You know, I've been a security engineer consultant for over 20 years. I've worked for some of the biggest companies in the world, some of the Fortune 50s, and I work for some of the smallest companies in the world. So I've got that sort of a very, very broad experience. So I've spent 15 years working for the Department of Defense and worked for a number of agencies in the government as well. So my background in IT and security is there's a very technical background, but a lot of how you advance in your career, we're going to talk about this, is really going to come down at how you present yourself and in how you problem solve, how you negotiate, right? One of the other little things, I love those little, you know, the icebreakers of tell us something you won't find on your resume. I spent the last 4 years as a political candidate. So when we talk about things like messaging, that's going to be something that we're going to really kind of hit on pretty hard, because it's really, really important and something that we miss. It's something that we all miss. Very quickly, owner of Mangold Security. I've been consulting, like I said, for almost 20 years. Adjunct professor at UCF. I teach topics in cybersecurity. I am the executive director for the Florida Cyber Alliance. We do a lot of summer camps for high school kids. I know a lot of folks in Bsides have actually been to our camps, which is really cool. And I am a director of Bsides. I don't have a lot of time today, but I do want to say we spent a lot of time trying to think about how to do this conference, and I am so grateful for the staff with Bsides. I've been a director since almost the beginning with Bsides, and you guys have done just a phenomenal job. This is really, really great, and I'm glad we're able to do this. Our biggest goal was we want to be able to do this, but we have to do it safely. So glad to be doing this today. All right, so let's get started. I'm going to talk very briefly about the overview here. We're going to talk a little bit about communication basics. This is not speech 101. I hated speech class. I do speeches all the time, and I hate speech class. But we're going to talk a little bit about sort of the background, because it is really important. And then we're going to talk about crafting a message. You've heard a lot about, maybe in political terms, things like that, about messaging. What is the message? We're going to talk about what that means and how you can use it. We're going to have a couple scenarios in there. I'm going to give you a negotiation checklist. I'm going to talk about choosing channels and timing and different techniques and tips and tricks. One of the things I do want to mention, though, is that nothing that I'm going to tell you is ever meant to be deceitful or coercive, right? These are things that you need to do as a communicator on your side to get your point across in the most effective way. So to preface this entire conversation, I do want to say this. This is kind of important. So that being a great communicator in and of itself will not make you successful. But if you are a terrible communicator, you will not get to where you want to be. Plain and simple. Talk to any hiring manager, ask them what their biggest problem is with hiring folks in like pen testing and so on. And the biggest issues that they'll have, the biggest issues they face by and large, are that you can get smart people. It's hard to get smart people who can actually talk and can actually communicate. So let's move forward. So we're going to talk about a little bit of the nerdy stuff first. So if you've taken any kind of speech class or anything like that, this is should be pretty familiar. So you are the sender. The person you're talking to is the receiver. And then there's a message that you are encoding in your own way that you're delivering to the receiver. Now, the interesting point about all of this, about this entire chart, and this is probably the most interesting thing about it, is the whole idea that you are encoding your message. You're encoding what you're trying to say, what you're trying to convey. The other person has to decode that, and they may not decode it properly, right? We're going to talk a little bit about some of that in terms of body language here in a couple minutes. But thinking about not just the message you have to present, not just the words you have to say, but thinking more in line of what is the message that I'm trying to get across? What am I trying to get this person to think about me, about my situation, that will actually influence them? Now, there's a lot of this that we can talk about. We could take this entire talk and turn around and call it a social engineering class. So this is just how people communicate. Of course, we always have a feedback loop. We try to get feedback. One of the difficult things with doing something like a Zoom presentation like this is I get no feedback. I am used to standing in front of audiences and seeing feedback, seeing head nods. You know, I teach, seeing students fall asleep. Like I'm used to that. I get none of that with this, which makes this very difficult, and it's something you have to overcome. And of course, noise. Everything is noise. You know, somebody's phone going off, everything like that. And you have to be able to get your message across, and you have to get it across succinctly and correctly. So I've said message a lot. So what is a message? A message isn't just what you're trying to say, right? A message is what you're trying to say along with what the other person needs to hear. So it's really more of deciding what your recipient needs to hear. It's how they need to hear it and how you're going to present that. It's putting it into this package of, I'm not going to ask for a raise. I'm going to say, hey, there's an emotional component here. My boss needs to understand, like, I'm having problems, right? And we need to make this happen. There's a much bigger bubble around this that is vastly different than, hey, I need more money. We'll talk some examples on that here in just a moment. So this idea of a message is, you know, you're not writing a speech. You're designing how to evoke an emotion that will elicit a reaction. It doesn't matter. It doesn't matter how technical you think you are. You make the majority of your decisions with some emotional basis to it. Either you don't believe what somebody says because you don't like them, and that's an emotion, or you believe the wrong things because you like the person, that's an emotion, or somebody gets that, you give somebody that raise because you like them more, or they made a more compelling story. It's all emotion, okay? Something that we talk a lot about in politics, again, sort of near and dear to my heart. And this is a phrase, and I use this all the time because it is absolutely true. This is Maya Angelou, a poet. She had this quote: "The people will forget what you said. They will forget what you did, but people will never forget how you made them feel." And it's absolutely true. I can tell you, running political campaigns, you know, nobody remembers that I sent a mailer out, right? What they remember is how they felt when they went to one of my events. Well, what they remember is they saw something that made them like or hate me on these mailers, right? They don't really remember the content. They don't remember the technical details. They remember what they walked away with. They remember the experience. It's so critically important, and it's something that we have to drive home in everything we do. And I want to give you a few examples on how this kind of plays out. You know, when we go and we have these conversations, these are conversations we've all had at some point. You know, if you go and you say, hey, we need a new firewall. What your boss actually heard was, I want you to buy me a thing. You didn't tell him why you needed a firewall, right? And you didn't really convey any emotion behind it. What if you went in and you said, hey, you know, we're really not as secure as we need to be, and I really think we need to look at getting a new firewall, and this is why, right? Much different conversation. You took that conversation from, hey, I want you to put another line item on your budget, to, hey, I care about this, and I know you do too. So let's talk about it. Instead of going and say, hey, I'd like a raise. Your boss hears, hey, I want more money. But what you really want them to hear is, I'm worth more. And you want to keep me, and you should give me more money, right? There's that alternate, it's a message. That's taking what you want to say and crafting a message out of it, right? Maybe you're on a help desk. You need to tell a user, hey, you need to change your password. And we know this. I mean, all of us have been on both sides of that help desk, right? Somebody says, hey, you need to change your password. And really what you're hearing is, yeah, so I'm making up a bunch of rules to make you angry. So you should do what I ask you to do. what if that message was something, hey, we all play part in security, and I really need you to do this because it's really going to help us all, right? Some of it is sort of softening the blow, softening the message, but what we're talking here is we're saying, hey, this is something we all deal with. We all have to do this. So let's do this together, right? And then the last one, no, you can't install Minesweeper. And of course the IT guys projected as being, oh, well, that person they just want, all the power. And I don't know how to mute my Discord. So somebody just told me to mute my Discord. But anyways, somebody, this idea of like, oh, well, you can't do this. It's like, well, the message there should be, hey, you're jeopardizing our security. And it's not that you're being malicious, but we can't have that. We can't do that, right? It's the idea of understanding there is a difference between what you say and what you mean. And sometimes there's a difference between what you say, what you mean, and really what you should mean. And that really comes into messaging. So let's walk through a quick scenario. And we're going to kind of play this out a little bit. Anyone who's seen any of my presentations, I love a good meme. So this is my opportunity to shine. So I call it the firewall scenario. So this guy named Steve, he's the head of IT for his company, been battling this janky old firewall. He decides it needs to be replaced, so Steve's got to go ask the boss. So here's Steve. So what does Steve do? He says, hey, boss, I need a new firewall. Struts on down the hallway and says, hey, boss, I need a new firewall. Well, we're going to end the scenario pretty quickly because we pretty much know what boss is going to say. By the way, don't call your boss boss, but we pretty much know that the response is going to be, okay, I'm busy, right? I've got other things to do, or something. You're going to get brushed off because you didn't message anything, right? You just went in there and you said, hey, this is my need. Didn't mean anything. Didn't mean anything to the recipient. Said you needed something. So don't be like Steve, plain and simple. And I want to kind of walk through this idea of this pre-negotiation checklist. There are a lot of things you have to do before you walk into any situation. Now, when I talk about negotiation, I want to kind of preface it a little bit. Anytime you are talking to somebody to try to convince them of something, you are negotiating in some way or another, whether it be sales. Now, there's people will pick apart definition in sales and negotiation, and it's all over the place. But what you're trying to do is persuasion. You're trying to convince somebody that your goal should be met, and you're going to meet somewhere in the middle. That's how we negotiate. That's how we get to consensus. Nothing in life is achieved by getting everything your way. I can promise you that. So we're going to walk through this little pre-negotiation checklist. Before you ever walk into one of these conversations, before you ever have this kind of this conversation with your boss, or an interview, or a client, or an end user, we have to understand some basic things. What are you looking to achieve? I'm trying to get a raise, right? Or I need this user to change their password, whatever it is. What are you looking to achieve? And what are you willing to accept? So it's easy to think about that in terms of a promotion, of a raise, right? What are you willing to accept? Well, I want, 200,000, but I'll take like 85K, right? Like what are you willing to accept in that range? What is your message? How are you going to take this thing that you're asking and make it more of a complete package? What are you actually going to say? Walk through it in your head. You're going to walk in. What are you going to say to start? You don't have to script everything. Don't script everything. When you script things, you'll mess it up almost every time. But what are you going to say? How are you going to open the conversation? Okay. If there's objections, how are you going to try to overcome those objections? Maybe the objection is, we just don't have the money in the budget. How are you going to overcome that? If you know that in advance, think about what you would say to overcome that objection. When are you going to have the conversation? When we're talking about raises right now, if you are in, for example, the hospitality industry, and you're looking for a raise right now, this may not be the best time to go ask your boss for a raise. Having a little bit of that social awareness of what's going on is going to be very, very helpful on the when. And then where will you have the conversation? Sometimes you need to do this face-to-face. Sometimes a Zoom meeting is good enough. Sometimes it's a phone call. Maybe sometimes it's an email, right? Sometimes emails to customers are exactly what you need. And there's this idea of choosing the right channel. And I want to show this little graphic, and it sort of rates the impact of different types of communication methods with the channel, right? I think what we're doing today is pretty impactful. We can have a conversation. Well, I can talk to you and you can eventually write back, right? We can have somewhat of a conversation. You can see me, you can see my facial expressions, you can see my emotions. I don't get much feedback, of course, but this is pretty high up there on the impact scale, but it's not as good as face-to-face, right? If you kind of go down that ladder, you go down that list, you know, phone calls, text messages, emails, letters, you know, some of these things you're going to have to add into the process. Maybe your boss is busy and you want to send off an email that says, hey, I'd like to get 15 minutes of your time when you have when you're available, right? It's a good first step. You don't need a lot of impact for that, but don't ask for a raise over email, right? Don't ask for that promotion over email. You need more impact. You need more face-to-face. You need to have that conversation, right? So some ideas here. And if we want to take that little bit of a touch of a political spin, this is exactly the same in politics, right? There is literally nothing in politics that will replace a candidate going to somebody's door or talking to them at an event face-to-face and having a conversation. Nothing is more impactful at all. Nothing is less impactful than bulk mail or yard signs, right? Those things do work, but the impact isn't there. You're not going to build that emotion around it. Again, we're talking a lot about elections, a lot of big elections news today, and actually just before we started this, a lot of good news. But we have a lot of these preconceived notions about what is a good channel, what is a good method. I mean, how much junk mail do you get every day that you throw away? How many vendor emails go to spam? All the time go to spam, right? How many LinkedIn requests do you get? You know, hey, it's funny, my first name on my LinkedIn is Lee V. My middle initial is V. So anytime somebody sends me an email that says, Dear Lee V, I know it came from LinkedIn, right to spam. Like, those are not impactful. You're not going to get my money. You're not going to get my business because I know you didn't care. So you got to be careful with some of those things too. And talk about timing and sequencing. You know, we talked a little bit about this a second ago. Is now the right time for the raise, right? Is now the right time when you should be walking into your boss's office, right? Like, don't get somebody right when they come in the door. Don't get somebody right before lunch and hold them up and stop them from going to lunch, right? Again, you know, the previous point was, you know, should you maybe preface this conversation with an email, or should you work an idea into an email before having that face-to-face conversation? You know, the firewall example, right? Maybe before we ever have that conversation, hey, this is what we need to do. Maybe that email that goes out says, hey, I'm investigating this, and I really think we need to have a conversation on it. Or this is some of the options that I'm thinking about, but I'll let you know, right? Maybe you preface that. It softens it up a little bit. It makes it easier for you, and it also sets a little expectation on the other side. Negotiation techniques, make it personal. Open with a plea, make it personal. That's how people make judgments. We don't want to believe it, but it's true. Get agreement. This is actually an old sales technique. Getting people to say yes. Get somebody to say yes. Get the person you're trying to get to ultimately give you a yes for the sale. Get them saying yes. Do you like this restaurant? Yes. Like, get them agreeing with you. You know, hey, do you think security is important, right? Yes, of course, right? Get them saying yes. It's funny, but it does work. Make your case, make it concise, and very important, if you can, make it a yes or no, right? Make that case and then shut up. This is the weirdest thing ever, but it's true. This is in politics when you're asking for donations, any kind of negotiation. When you make that case, stop talking. The only thing you're going to do is make it easier for the other person to say no. Stop talking, let them say yes or no. But either way, you'll have an answer. But be willing to leave, right? If you don't get what you came for, be willing to walk out, right? And that's not necessarily taking the the machismo, stance at it. That is knowing where you have a little bit of pride. And by the way, when you walk out because somebody was kind of testing you, they know you were serious, right? That makes it even more personal. Don't be rude. Don't flip your boss's desk and walk out. Like that's not what we're saying here. But be willing to walk away. Sometimes you have to. Sometimes it doesn't make sense not to. We're talking about that scenario again. So here Steve comes back in the office, says, hey, boss, I've been concerned about our security lately. I want to sit down and discuss. Do you have a moment? Right? Now think about how that works out. Sure, come on in, have a seat. All it is a friendly conversation. Come on in, have a seat. Right? The firewall we're using is out of date, needs to be replaced. Can I show you some options? Now, Steve has done his homework. He has his options. He wants to talk about this from a very objective, hey, I have some options. We're insecure. We need to be secure. And of course, sure, what do you have? Well, Steve says, hey, after, goes through his whole thing. So after seeing the options, would you like to move forward with firewall option A? Or I would like to. Would you agree with that? Again, yes, no question. And that's where the answer comes with, yeah, sure, go ahead and get me a quote. Get me that final quote. Or maybe it's, yeah, let's do it. Right? That's the difference between building a message, delivering it appropriately, and even in this case, he did his homework, he delivered it in stages, right? But that's that case of how you make somebody get an emotional attachment to what you're emotionally attached to, and then get them to see it your way. It's the basis behind so much communication. We all have, sort of that emotional drive that really kind of gets us through the day, right? We want people to be more secure, not because, of the company necessarily, but we want people to be more secure because it's the right thing to do, right? We want people to be more secure with PII, personally identifiable information, or healthcare records, not because of the law, but because it's the right thing to do. How do you take your passion for it's the right thing to do and convey that in your message, right? By the way, don't tell anyone it's the right thing to do. Like say different words because you don't want to try to enforce your emotion onto somebody. You want them to get the idea, right? So some more tips and tricks here. We're getting close to the end here, but some of these are pretty interesting, and some of them may sound like tricks. I promise, well, except for maybe the last one. They're not tricks. They're just ways things you need to think about. Using we instead of I, right? You notice in my presentation, I do this unconsciously now. And you have to be careful sometimes, but I do this unconsciously. I was talking about Bsides and how we spent a lot of time doing this. We put this together. I'm very proud of everyone else because blah, blah, blah. It was always we, it wasn't I, right? It's very important. Now, that can bite you sometimes. You do have to use that I every once in a while when you're talking about yourself. This is something I'm guilty of. I don't talk about the cool stuff I do a lot, but I do talk about what we do as a team. It's very, very powerful, and depending on your corporate culture, that could be perceived as just an amazing thing. We want a team player, right? We want somebody who builds a team. Don't volunteer objections, right? Don't walk in and say, all right, listen, this might not work, but don't do that. Don't do that. Especially don't do that when you've made the ask. Remember I said make that ask, make your case, and then shut up. Don't make your case. I'll give you a good donation example, right? Would you be willing to donate $50? I know it's a lot of money, but don't do that. You just made it easy for the other person to say, nah, I'm not interested. Right? Don't do it. Showing empathy towards objection. Okay, this is good for just general being a polite person and a good communicator. It's also good for coming back for more later, right? But also it can actually change a conversation. If somebody says, oh, they give you this objection. They say, oh, well, we have a lot of money. We don't have a lot of money and we're spending it on X, Y, and Z. So, oh, I agree. I understand that. And what I really think would be helpful is if we could take some of that money and funnel it into IT investment to help us pay off some, magic figure in the end, right? Agree, and modify. Very, very powerful because what it does is it actually takes that person's thought and it adds to their thought. And if you do it right, they think that was their thought. Body language. Okay, body language is huge, and it's huge for a couple really big reasons. You know, I'm doing this presentation. I'm kind of moving. I'm open. I'm doing my thing here, and it seems like should anyways, hopefully, a pretty friendly, approachable conversation, right? That's what we're going for. What if I did this whole presentation like this, and I just kind of talk like this, and you know, I might still be passionate about what I'm doing, but you know, it's my body language, it's how I talk. I'm a smart guy, and you should just understand I don't need body language to prove it, right? No, that's not how people communicate. That's not how it works. Okay, body language is important. The other thing too with body language is it's a well-known psychological trick for yourself. Okay, when you have, you know, broad span, when you're open, your chest is out, your arms, you're loose, you're relaxed, you look relaxed, you look approachable, you look like you've got it together. Okay, but if you make yourself do that before a presentation, before giving that speech, before talking to your boss, make yourself do that before you even go in the room, and do it for a little while. You will actually start to feel the same thing. You will start, I forget what the principle is, but you will start to feel the exact same way that you're trying to mimic. Now, the last thing here is a little bit weird, okay? This is something called mirroring. It's actually a pretty interesting negotiation technique. This is like the advanced side. Mirroring is when you take certain actions or certain keywords or phrases that the other party, your receiver of your conversation, is doing, and you mimic them. If you're on here and you're wide open and the person you're talking to is like this, right? You know what you need to do? Agree. Because when you mimic them, you're agreeing with their emotions. They don't know it. If you do it right, they don't know it. Now, don't do it immediately. Like somebody scratches their head, don't you immediately scratch your head. Like, don't do that. That's not what I was saying. But if they're leaning back, you lean back. If they're leaning forward, that's what you do, right? Mirror what they're doing. If they use certain keywords, don't keep trying to force your jargon down their throat, right? Use their keywords. Speak their language. Remember what I said about messaging in the very beginning. It's not about what you have to say. It's what they need to hear, right? So very interesting. Mirroring is worth practicing. Practice very lightly, but it is extremely effective. So closing notes here, and we're about at the end of our time. You know, always go in with a plan. Right? Don't walk in and say, hey, I need X, Y, Z. No, think about that conversation. If it's important enough to have a stressful conversation, you get that ball in your chest, and oh, I'm gonna have this rough conversation, right? If it's important enough to make you feel like that, it's important enough to plan, right? Tell people what they need to hear, not what you want them to hear. You have to message. You have to bring all of these ideas together into one cohesive thing and message that. Choose the right channel and choose the right time. We talked about that a little bit. And then, of course, finally, at the end, we win. And by winning, we convince somebody else to take our passion, to take what we're excited about, what we're interested in, and what we know is the right thing to do, and make it as important to them as it is to you. So you end up getting your way in security, and you'll end up getting your way in life. Thank you all so much. If you have any questions, I'm sure they'll pop up here shortly, but hopefully that's helpful. And that's it.
Hey, thank you so much. That was fascinating. And you're right, it's not something that you see covered at a lot of these technical conferences, but it is so valid, not just in our community here in security, but it's whatever you're trying to accomplish in life. This works with your boss and your toddler, quite frankly.
It does.
It's the same sort of practice.
Mm-hmm.
So at this point, I'm looking in the Discord and I don't see any specific questions coming up. A lot of comments that you've got going on in there. I wanted to ask, do you have any additional resources that folks could dig into, any books or podcasts or anything like that you might recommend?
I can drop some into the lobby. There's a couple really, really good books on FBI interrogation techniques that are just very deep psychologically, illuminating, I guess you would say.
Yeah,
Sure.
awesome. Well, I think that's all we've got for today then. And if you want to ask Lee more questions, go hop into the either Track 4 live chat or the Track 4 lobby. And
All right.
we'll be back after lunch with a new stream for Track 4 and continue on our day. Thank you.
Thanks, everyone.
Well, I think it's